Assalamualaikum. My name is Mohamad NAZMI bin NORDIN. My matrix number is CD210297. First, introduction. A nozzle in thermodynamics is a device that is used to convert the pressure energy of a fluid into kinetic energy. The fluid flows through the nozzle and it accelerates as it passes through a constriction in the device, which results in an increase in velocity. The nozzle also causes the fluid to expand, which results in a decrease in pressure. This process is known as adiabatic expansion. Nozzles are commonly used in applications such as engines, turbines, and pumps to increase the velocity of a fluid, and are designed to produce a high-velocity, low-pressure fluid stream. The design of a nozzle can greatly impact the efficiency of the system in which it is used, and the different types of nozzle are used for different applications and fluids. Next is objective and scopes. 1. To understand how nozzles can maximize efficiency of the system where they are used. Second, to understand the law of the thermodynamic function of a nozzle in everyday use in life. And third, to learn how nozzles are able to maintain a specific flow rate and generate specific flow pattern. The general and the specific target steady flow device. A specific target steady flow device in thermodynamics is a device that is designed to maintain a specific flow rate of a fluid at a steady state. These devices are typically used in applications where the flow rate of a fluid needs to be precisely controlled, such as in a power generation, chemical processing, and HVAC system. Example of a specific target steady flow device include flow meters, flow controllers, and flow regulators. Flow meters measure the flow rate of a fluid, while flow controllers and flow regulators are used to adjust the flow rate to a specific target value.
Assalamualaikum and salam sejahtera. My name is Mohamad Amirdanial bin Hamzah. My matric number is CD210308. In this slide, I would like to explain about the methodology. Review of first law and steady flow device, SFD. First law of thermodynamics is the energy can be either created or destroyed, only convert from one form to another form. Steady flow device, SFD, is a device that can continuously deliver or remove energy from a system at a constant rate, such as a nozzle. Okay, next. General energy equation for first law of thermodynamics. Okay, based on the slide, we have shown the formula that used for the first law equation. This is the steady state equation, energy balance, and then nothing energy can be transferred, like heat, work, and mass only. This is all the equation that can be used for first law thermodynamics. Okay, next, continue from the previous slide that I show. This is the table for first law that we use to as a instruction. This is the nozzle, the device that our group choose, and then this is the symbols, the example picture, the formula that nozzle use to get the answer, like energy balance, steady flow. This is the unit, and so on.
Okay, Assalamualaikum. My name is Muhammad bin JOHAN. Okay, now I will continue about the applications of SSFD. Okay, first, the application first is steam turbine. Steam turbine work in a typical manner. They force a high-pressure steam through multiple sets of blades and generate energy in doing so. In simpler terms, a steam turbine works by heating water to very high temperature until it converts into steam. The steam produced in the process is used to rotate the blades of the turbine and produce rotational or mechanical energy. Okay. Secondly, the application of SSFD nozzles is gas turbine. A continuous flow internal combustion engine is referred to as a gas turbine or combustion turbine. The gas generator needs to have extra parts to fit its intended use. An air intake is a feature that all have in common, although they are all configured differently to meet the needs of flying at different speeds, from supersonic to stationary to land use. Thirdly, water turbine. A water turbine is a rotating device that uses the potential and kinetic energy of water to produce mechanical work. Prior to the development of electrical grids, water turbines were a common source of industrial power. They are now mostly employed in the production of electricity. Most often found in dams, water turbines use the potential energy of water to produce electricity. Okay. Next is jet engine. An example of a response engine is a jet engine, which emits a swiftly moving jet of heated gas, often air, to provide thrust through jet propulsion. The phrase jet engine normally refers to an internal combustion air-breathing jet engine such as turbojet, turbofan, ramjet, or hose jet. Finally is injectors for pumping feed water to boilers. The injector is the instrument used to feed water into the boilers. It is usually employed where space is not available to implement a feed pump, used for vertical and locomotive boilers. In an injector, the water is delivered to the boilers by steam pressure or using nozzle. The kinetic energy of the steam is used to increase the pressure and velocity of the feed water. The steam pipe, the water pipe for the water inflow, and the delivery cone, which is where the pressured water exit, are all present by the nozzle. Thank you. That's all from me.
So, case study. Simulation of steady flow device. So, we get the question. Steam enter a nozzle at 400 Celsius and 800 kilopascal with velocity of 10 meter per second, and leave at 300 Celsius and 200 kilopascal while losing heat at rate of 25 kilowatt. For an inlet area of 800 centimeters square, determine the velocity and the volume flow rate of the steam at the nozzle axis. So we solve the case study using the formula and using this what we study in thermodynamics subject. So we get the answer like we write in our report. So the highlight and the result of the study. The study of nozzle in thermodynamics involve a combination of theoretical analysis and experimentation. An experiment can include measuring the flow rate, velocity, and pressure of the fluid as it flows through the nozzle, as well as thermodynamic properties such as temperature and enthalpy. Nozzle study also involve the use of various diagrams and tables to help visual and understand the behavior of the fluids in a flow through the nozzle. As the result from the case study, the value flow rate at the exit is 2.74 meter higher than the inner volume flow rates. So next, the reasonable of the case study. From the theory, assume the volume flow rate is exit equal to the inner volume flow rate. Other than that, the meter inner is bigger than the exit diameter because the velocity exit is higher. From the nozzle free body diagram, the V2 must be higher than V1 and the pressure inner and exit is different. Nozzle in thermodynamics is a device to convert pressure energy of fluids into kinetic energy by acquiring fluid through a concentration, causing antibate expansion and decrease in the pressure. The design of nozzle is crucial in many applications like engine, turbine, pump, and theory chemistry of the rocket propulsion system. So that's all for me for this case study. Thank you. For the conclusion, a nozzle thermodynamic is a device that is used to create a fluid, typically a gas, to high velocity by concentration of the flow passes. The conclusion of nozzle in thermodynamics is that the nozzle is an important component in many systems, particularly those involving the conversion of the thermal energy to kinetic energy, such as in gas turbine engine, rocket propulsion system, and industry process. The performance of a nozzle is characterized by its ability to convert the thermal energy of a fluid to kinetic energy, which is measured by the nozzle thrust and efficiency. The design and optimization of nozzle is complex and ongoing field of the study in thermodynamics. So that's all from our group. Thank you.